Question 46 says a body is released from rest from top of a tower of height 3h. The ratio of the intervals of time to cover the three equal heights h is. Dear students, the time taken to cover the first height h will be equal to under root 2h by g. It is from the concept of the free fall from rest. In the second height h, the time can be written as the total time taken to cover the height 2h minus the initial time taken, that is t1, that will be 2h by g. So this can be written as under root of 2h by g root of 2 minus 1. In the third case, the time for the last height h can be written as the total time taken, that will be 2 into 3h by g minus the initial time, that is t1 plus t2, that is the total time taken till the height 2h is covered. So this will be equal to under root of 4h by g, and on simplification this gives us a value of under root 2h by g multiplied by root 3 minus root 2. We can clearly see that in t1, t2 and t3 this factor is common, that is root 2h by g, and the corresponding ratio can also be written, that is t1 ratio t2 ratio t3 will be equal to 1 ratio root 2 minus 1 ratio root 3 minus root 2, and hence for this question the correct answer is option number 4. Now let us move to the question number 47. Question 47 says centripetal acceleration in uniform circular motion is first a constant vector, second not a constant vector, third a constant scalar, or fourth a magnitude changing vector. Dear student, let this be the circular path. Just if the particle is at this point, let this be the point P1, then the centripetal acceleration will be directed in this direction. When it will be at this point P2, it will be directed at this direction. Similarly, at any arbitrary point P3, the centripetal acceleration will be directed at this direction. Since the centripetal acceleration is always directed towards the center from the particle, its direction will always change. However, the magnitude of the centripetal acceleration will be equal to v square by r. And in the uniform circular motion, since the speed is same, the magnitude of the centripetal acceleration, that is the magnitude, is constant. Therefore, it is a vector whose direction continuously changes. Now let us analyze the four options. First, it says a constant vector. It is not a constant vector because the direction is changing. Second, not a constant vector. This is a correct option. Third, a constant scalar. Dear students, it is also wrong because centripetal acceleration is not a scalar. Or fourth, a magnitude changing vector. It is also incorrect as the magnitude of the centripetal acceleration does not change. Therefore, for this question, the correct answer is option number 2. Now let us move to the question number 48. Question 48 says a sphere encloses an electric dipole within it. The total electric flux through the sphere is, four options: 0, double of that of a single charge, third half of that due to a single charge, or fourth dependent on the position of the dipole inside the sphere. Dear students, the total charge on a dipole is equal to 0 as it composes of equal and opposite charges. And as per the Gauss's law, the flux, that is the electric flux, is equal to the enclosed net charge divided by epsilon naught. And in this case, the enclosed net charge will be equal to 0. So 0 by epsilon naught will give us a value of 0. Therefore, in this case, the total electric flux through this sphere will be equal to 0. And hence, for this question, the correct answer turns out to be option number 1. Now, let us solve the question number 49. Question 49 says E is the energy of the electron in the nth orbit of the hydrogen atom. Then the energy of the electron in nth orbit of the He plus will be. Now, dear students, the energy in any nth orbit is given as Z square by n square into 13.6 electron volt with a negative sign. Now, for He plus atom, this will be equal to minus of 2 square by n square into 13.6. Clearly, this is 2 square times the corresponding energy in hydrogen atom, and therefore E dash will be equal to 4E, that is 2 square E. And hence, for this question, the correct answer turns out to be option number 3. Now, let us move to the question number 50. Question 50 says the equivalent resistance of a circuit as shown in the figure between point A and B if VA is less than VB is. So, four options are 10 ohms, 5 ohms, 20 ohms and 15 ohms. Dear students, it is given that VA is less than VB. So this particular diode is reversed biased. And in reversed biased, this can be assumed to be offering an infinite resistance and the circuit will be broken here. We can simplify the circuit diagram and draw the circuit diagram again. On the top there will be a resistance of 10 ohms. At the bottom there will be a resistance of 10 ohms, but the circuit will be broken. So effectively only 10 ohm resistance is there, and hence for this question the correct answer is option number 1. Dear students, this concludes the discussion on the solutions of the mock test 1 of the pre-NEET test series. I hope you understood all the solutions. Thank you for watching and best of luck for your future endeavors.